I'll tell you what, I'll just make a start because it's recorded anyway. So I've got some good news. Just before this call, I was talking to the pediatric oncology expert who diagnoses children with diseases like acute lymphoblastic leukemia. So he is available on Friday at 3 o'clock GMT, so the same time as we meet now. And he can do a 45 minutes call. And what he is going to run through is basically about the disease, how it affects children, how it presents itself, and how they currently diagnose this disease. And what are the sort of the tests that they currently use, what kind of AI they use at the moment, and where he thinks the scope of our project would fit into the diagnostics. So we're quite lucky to get him. His name is Dr. Neil Barrett. So what I will do is send out invites on Friday for the Friday meeting. Please, get there if you can. It'll be good to ask any questions. But the general idea of that meeting is to give a bit of context around the disease, just to allow everyone on the project to get a deeper understanding of what the disease is. That may help you in your research, but it also might, raise a couple of interesting points that you may consider incorporating into the model somehow. It might not, but I think overall having a deeper understanding of the disease that we're trying to identify will, be beneficial for everyone, whether or not it's reflected into the into our project at the moment. So it was quite an interesting conversation. As I say, I'll get them invites out as soon as this call's finished, and I hope everyone can attend. So let's see who we've got on the call. So in terms of our project, we've split into two teams. Oase has had a team meeting already. Pranjal, I think he said Friday was his meeting with his team. Other than that, though, has anyone done any further work or further research into our project and different methodologies we could approach that who would like to share with the group at this time? There's no pressure whatsoever. I know it's still only early days, and there's been quite a lot of discussion. Neville, you've got your hand raised.
Actually, we had done some work with I was actually on team 1 with Oase, and we've been doing some. He's like doing good work with the data augmentation, data transformation, cool. And cool. It's been very good, especially for beginners as well.
Yeah, yeah.
No, so that's good to hear. The idea is like just to run the model, run everything right now, see where we are, and then we can just add on later.
Yeah, that's perfect. Yeah. Is there any discussion around because you're doing the feature extraction?
Yeah.
With is there been any sort of discussion about what model to use for the feature extraction? Because there is a number of very effective models.
Yeah, so he has shown AlexNet, VGG, and I forgot the other one, but he's shown 3. Cool. So we'll use those. Cool. We'll use transfer learning, get the features, and then put it into the model.
Yeah, no, that's perfect. No, it sounds good. Yeah, always. I've worked with Oase on a couple of projects, and he's always very good at building the work and getting it out there rapidly. And he's a very talented data scientist. But yeah, no, that's good. That's good to hear. There's been a couple of people join. Let me just update you. We've got a talk with an expert in this particular disease on Friday, and it's at 3 o'clock GMT. So the same time as now, basically. I'll send the invites out today after this call, and his name is Dr. Neil Barrett, and he's currently in he's based in a hospital in Ireland, and he diagnoses these types of diseases, you know, unfortunately more regularly than he should. He was telling me the most recent one, you know, he's diagnosed this particular disease within the last week. He'll go over how the disease manifests, what kinds of protocols they use to diagnose it, and where he thinks the scope of our project would fit into his working life. So he's a very, very, very knowledgeable guy, as you can imagine, and I think it will be beneficial for everyone to get a deeper understanding of the disease that we're working with and how our project could benefit the diagnosis of them diseases. Like with all cancers, the earlier you catch them, the better. The prognosis, basically. So yeah, I'm looking forward to that. That should be good, and it's a real great opportunity for everyone to learn more and speak to someone directly in the field who's diagnosing this disease and has first-hand experience of it. So yeah, that's what that's something to look forward to on Friday. Of course, it's going to be recorded, but I'd like to see a good turnout. He is donating his time, and it would be very appreciative if we do come and make notes, ask him a couple of questions about the disease if there's anything unclear. He's not in any way an AI expert, but that's not his job. But he uses AI. There's something he uses called clear vision, which is to detect and monitor blood cells and the counter blood cells and things like that, and they use that. So he is aware of the potential it does have. So he was quite excited to hear about our project, and especially around in hospitals that may be under-resourced and things like that. So yeah, it'll be a great opportunity for everyone. For those who have joined recently, is there anything you guys would like to share about what you've been working on? Any interesting observations you've made with the work that's currently gone on at all? Feel free to share it. You can share your screen or just talk about it. If you've got any questions about what you've seen so far, please raise your hand and we can go through that. If not, we can have a short meeting. As I say, these Wednesday calls are only updates, catch-ups. They're not really formal at all. Saturday, Team 1 and Team 2 will be sort of giving a presentation on what they've done in the previous week. Any positives, any negatives that they ran into, any considerations for each other and things like that. So that's our main one. Don't worry about this one too much. But yeah, has anyone got anything to share at all? Neville, go on.
Actually, I had done something. This was not regarding with the team effort, though. It was something on my own I did. And it was regarding a method called, it's a data augmentation technique. I'm not sure if this will actually make as much of a difference, though. It's called contrast limited adaptive histogram equalization. So I've done it. If I can show my screen.
Yeah, go on, share your screen. I'll go on mute.
I've not made any presentation or anything, but yeah, so this, it's pretty much catered towards beginners as well. So I've made it as explanatory as possible. So basically, I'm pretty much just calling the libraries, creating the variable paths and so on and so forth, and then importing the images. After that, I just convert it into arrays. So basically, right now, I'm just trying to visualize the two cells, infected and the healthy one. Then here, I'm actually converting it into a grayscale, but this eventually just adds on in the end, because this is what's necessary for doing the data augmentation. So this one is actually a very short code because a lot of it is already there. But the functionality is already there. So the most you're going to be working with is the clip limit and the grid size. These are two parameters that you're going to be working with for creating the contrast limited adaptive histogram equalization method. So basically, what I did was I tried to highlight a lot of the important parts of the cell. The difference between the normal adaptive limited histogram equalization method is that the original one like over amplifies it and it gives a lot more noise to the image. This one, however, doesn't over amplify the image as much. So then I had cropped it, and just to, show a little bit more detail, basically I just wanted to highlight some of the areas where it could be important, but I'm still working on trying to make it more detailed as possible.
Yeah, no, that's really good. Like, even to the untrained eye, there's certainly a difference between the infected and healthy cell when the contrast is raised, which isn't identifiable in the original images. So, you're pretty much giving the model more to work on, which is quite interesting. Now, we don't know whether that's going to be a positive or negative until we try it, but it's these kind of experiments which will definitely, if you've got, you can set up 3 different experiments with 3 different methods of augmentation, see which ones work the best. But that's, to the untrained eye, you can see that there certainly is a difference, which is really, really good. It's great work. Yeah, and I shared. If you can, have you uploaded this notebook to the GitHub or shared it into the Slack?
Into
Perfect.
the knowledge sharing folder. Yeah.
Nice. Okay. Great. I'll share that and I'll take a look. That's really good work.
Yeah. I want to find out why do you need to convert it to grayscale?
So apparently this type of method requires it for grayscale conversion. I looked at the official docs and they convert it into, they use a gray image. I had tried converting it into HSV, but that didn't work out. So only gray was only the only option.
Okay, thank you. So is this notebook available?
Yeah, it's there I've shared it on the group. So basically you can easily just try out different values and stuff. So for example, the cropping, I've added example, you can change 390, the values here, and you can see the difference in the image.
Okay.
So it's mostly just trial and error. You can see the effects.
Okay. Is it on the general group or the team 2 group?
It's on the GitHub knowledge sharing.
Knowledge sharing. Okay.
Yeah, the general reason why a lot of computer vision tasks require grayscale, it's usually around the one, the computational needs, because if there's more colors, it has to process more data. And if it's only got, a grayscale image to look at, it doesn't have to, the algorithm that is being used doesn't have to be very complex. It's sort of, you could probably compare it to dimensionality reduction in like a tabular data set. It's the same sort of idea. Is it necessary? No, but it helps a lot in terms of, as I said, computation and model complexity as well. It's generally a good idea to do it. From my experience, when things go into production, there might not, it might not be necessarily, but certainly with experimentation, it's probably easier to make them grayscale. It's faster, and it doesn't, it doesn't allow the model a lot of thinking time, kind of thing. So they're generally the reasons why we grayscale the images. And I imagine this particular method is exactly if it's only highlighting a couple of colors, it's better than having a full RGB spectrum, if you know what I mean. So that's generally why.
And apart from that, there's also a reason, like just like you mentioned about complexities. So in RGB, we have three-dimensional, but converting to gray obviously reduce it to two. So apart from the complexity factor, many algorithms just work on grayscale. So that is another reason why we have to convert it to grayscale, because one of the a few important algorithms through which we process the images accept only grayscale.
Yeah, that's true. A lot of deep learning algorithms also need grayscale.
Yeah, I think the official term is signal to noise, if I remember. It's that kind of thing. But yeah, that's absolutely right. Yeah, no, that's really good work, and I think it's really useful that you've shared that as well. As I say, from even just looking at it with an untrained eye, you can see there's certainly differences between the sort of geometry of a healthy cell and the geometry of a disease cell. So yeah, really good work. I've just seen in the chat pop up, Manasseh, you didn't get the invite to the GitHub. I'll invite you again. I'm sure I've done that, But sometimes though, they expire as well. They expire quite quickly. So a lot of the people I've had to re-invite. So it's a bit of a pain, but I'll get on that, Manasseh. Don't worry, I'll do that right now. Okay, has anyone else got anything that they'd like to share with the group that they've been working on, or any interesting insights that they've come across?
I mean, I just want to add on that.
Yeah, go on.
So you can do this equalization process, histogram equalization on multiple channels also, but with grayscales, it's easier to compute the histogram. So, I mean, think of it as if you have a color channel, you have to have multiple channels representing the intensity values for each color channels, right? So this histogram equalization would need to apply it separately to each color channels. So that's why it's just to reduce the computation time. It's done.
Yeah, absolutely.
But it's not mandatory. I mean, you can use it if you have good compute resources. You can use it for multiple channels even.
Yeah, that's the thing. I mean, when I was experimenting myself with this particular data set, I didn't grayscale them because I'm lucky enough to have a decent laptop built for machine learning. So it was quite cool. But if I'm just running quick experiments and don't want to eat up all my resources, grayscale is the way, 100%.
Yes.
So I'll just reiterate again. Sorry for repeating myself, but a few more people have joined that probably didn't hear previously. On Friday, same time as this meeting, 3 o'clock GMT, we've got an expert in pediatric oncology, Dr. Neil Barrett. He's going to spend 45 minutes talking about acute lymphoblastic leukemia, how it's diagnosed, how it presents itself, and what sort of AI they use right now, but also he wants to, he's quite interested in our project, and he wants to see, give his opinion on the scope of our work, where he thinks it would fit up in that diagnosis chain, what kind of places would benefit from this kind of technologies and whatnot. So, it'll be a very insightful call. It'll be very useful to understand the context of the disease while we're working on a model to build something that can diagnose it. And that is, we may not use Dr. Barrett's insights directly, but I think it will benefit us having that knowledge about the disease. If you certainly, if you go into a data science position, or in the industry, or machine learning, or whatever you want to do, and part of your portfolio is this project, I imagine that it will conjure up a few questions from the interview panel. And yeah, you can talk about the technical side, but if you can't bolster that with at least a little bit of knowledge about the disease and the problem you were trying to solve, it probably won't fall as well. So the more you know about the disease, the better. And I think this is an excellent opportunity to talk directly to someone who deals and diagnoses this disease every single day. So, yeah, it's going to be recorded, but I think just out of respect for Dr. Barrett's time, it would be, I'd like to see as many faces as possible. I'm certainly going to be there. And it's an opportunity as well to ask some questions that may be about the disease that may help you in your research into developing a solution for this project as well. So it'll be good to certainly attend. He's a nice guy. He's very straightforward. I actually met him on Twitter, just through other means, and it just so happened that he was an expert in pediatric oncology. And I met him far beyond far before I even thought about this particular project or putting it together. So yeah, it was a great coincidence that we will utilize and get the benefit from. So please, I'm going to send the invites after this call, so please try your best to attend. It'll be as I say, it'll be a great learning experience. Okay, is there anything else anyone wants to share? If not, we can call it a day and I can give you all the time back. As I say, the Wednesdays are only informal catch-ups. If anyone wants to ask any questions or just check in and see how we're all doing.
Hello, Rich.
Hello.
Yeah, the GitHub repo page. It seems most of us didn't get the invite, so I was wondering maybe if it's possible to share the link in Slack or something. Just thinking about.
Yeah. See what happens is I have to individually invite people, and more often than not, these invites go into people's spam boxes, or they don't get them at all, and then the invites go invalid. So I think the best way around it, if you haven't got access to it, I'll share the link in the Slack channel. If you haven't got access to it, just message me or just tag me in a Slack thing, and it's probably easier me doing that one because I've completed the whole list now. And I know a lot of, I think there's nearly 200 people in our channel, and there's not 200 people working on this project at the moment. There's about 30 other who are active participants. So if you're an active participant, send me a message and I'll add you to the GitHub. It's just one of them things. They don't allow mass invitations. And I'm not the creator of that GitHub either. It's created by Omdena, so I can't even, when it was created, add everyone who was on the project kind of thing. And again, you get limitations as well, how many people you can invite. So it's a bit of a pain, but if you just message me with your email for GitHub, I'll add you to it. Neville?
Actually, wouldn't it be better to actually make it as a public repo, because at least they can see it?
Yeah, that is not in my control. That is Omdena. They make it private until the project's done, and then they make it public. It's just one of the stipulations. It's out of my control, that one, unfortunately.
Okay.
I tried to do that with the last one as well, but they said no. So it's just one of them things.
Okay. All right.
Yeah. Okay, so yeah, I think the best minute, just batter me on Slack. I add, you've seen me reply to everyone. If you message me, I add you to it. It's just, unfortunately, that's just the trials and tribulations of having a project on GitHub. But yeah, if anyone hasn't got anything to share, we can call it a day there. I'll send the invite for Friday's meeting with Dr. Neil Barrett, and I hope everyone can attend. But yeah, if that's it, have a great day, everyone. Thanks for coming, and I'll put this on YouTube as soon as possible. Have a good day.
You too. Thank you.
You too. Thank you.